right, I guess we can get started. My name's Hugh Peterson. I'm the product manager for Standard Imaging, cover our water phantoms and a few other products, including our PIPS Pro software for TG142 QA for machine QA, as well as our daily devices, Beam Checker Plus, etc. Today I'm going to be talking about the DoseView 3D water phantom, and we've introduced this about 10, 11 years ago, I guess now, and we actually are in our second generation of the hardware, which I'll kind of touch on a little bit as we go through. And we've also basically rewritten the software from the ground up, and I'm going to run through the software as well to show you just how quick and easy the software is as well. But what makes a good water phantom? Obviously, you're going to be wanting to do a number of different objectives: your acceptance testing, your commissioning, your annual QA, and then if there's any kind of like a preventive maintenance or any downtime with your Linac and a service was performed, you may need to do some periodic checks as well. And what does make a good water phantom? Obviously there's a number of features that you're looking for in a water phantom. You obviously want those highly accurate and repeatable positions. You want that high quality raw measurements. As I mentioned, you want to do as little post-scan processing as you can or need to. You want to kind of get a what you see is what you get kind of result from your water phantom. You want reliable hardware operation. This is best case scenario, something you only use annually. So you want it to be at the ready when you pull it out of storage at those intervals. You want easy setup and use, since again, it may only be used on an annual basis. You want to be able to pull it out, set it up, and get going quickly, and not have to kind of relearn everything about the system. And you want that flexibility, flexibility to use any type of detector for the most part. Allow it to do results for different protocols, be it the AAPM task group protocols or the IAC protocols, et cetera. And you want to be able to of course, bring it into any number of treatment planning systems and have the different formats available for that export and import into the treatment planning system. It all comes down to helping you do things more streamlined and more efficiently, and that's kind of one of the strengths of the DoseView. And why is my PowerPoint not moving? There we go. So, as I kind of mentioned at the top, we really take great pains to produce a very robust, very accurate system. And within that consistency and your accuracy, we utilize heavy gauged extruded aluminum frame that maximizes the rigidity. We have machined corner braces as well, so there's very little flexion, very little misalignments with the system. We use redundant motors across the larger axes of the Phantom, so you don't get any flexion or cantilevering there. They're calibrated together so they move in unison. Positional accuracies are all repeatable and within 0.1 millimeter per axis. That's all three axes of the Phantom, the X, Y, and Z axes, and it allows for a quick and precise 3-point leveling. We don't have a automatic leveling because we've done some research and we've looked into that, and we think that the basic capability that we have and the process that we have is very quick. It's just as quick, if not faster, actually, than some of the auto leveling, and I'll touch on that in a little bit. But you can be up and scanning after the tank is filled with water. You can do your leveling and ready for scanning in about 15 minutes. So it's pretty quick. It's no faster or slower. But it's a little more easy than some of the auto leveling systems out there. And even before the systems go out the door, we do a 39-point check across the Phantom with an industrial coordinate measurement system that assures those accuracies before, like I said, before it even goes out the door, so we can assure that those point one accuracies are maintained. So just some of the unique features we've used in our system to kind of help make things easier for the measuring physicist. The water tank and the frame are mechanically secured together, so that gives you that long-term integrity. It allows you to assure that accuracy as well. We've got a fully integrated lift cart and reservoir that is available, and that gives you the ability to fill and drain the water phantom without having an external reservoir, which some people like. If you prefer a lift cart only, that is available as well. Then we also have a just kind of a nice feature is what we call an advanced suction drain. It's got a little moat system around the tank, and the a suction wedge is what we call it, for lack of better terms. But it actually pulls the vast majority of the water out. So none of the robot or none of the scanning arms are sitting in residual water after you drain the tank. So it keeps if you're not using distilled water or deionized water, it keeps mineralization off of the arms of the tank itself and the robot. So it just a nice little feature there. We have a very unique positioning platform as well. Once you get the system into place under the collimator, you have the ability to do some fine adjustment with the levers you see there. There's X and Y direction and a rotational one, which gives you a nice fine tuning of the position of the water phantom once you get it into its course position. And then there's also locking points for your 45-degree increments as you rotate it for doing diagonals. It kind of clicks into place, so you know when you're at your 45s if you are going to be doing diagonal scanning. As I mentioned, this is our second generation design for the hardware, and it's a little bit lower profile. It's a little smaller, but you still can do your full size field size scans with that compacted design, and it not only improves rigidity in the corners and the movement of the robot itself, but it also now is Halcyon and Ethos compatible, so it will fit in the bore of the Halcyon system. And we do have a specific fill line on the etched on the side of the tank for the Halcyon fill. Obviously, excuse me, being about a 60-gallon tank, that would exceed the couch limitations for the Halcyon system. So we have that lower fill line that still gives you depth measurements for 6 MV of the Halcyon, but does not exceed the couch limitations. Additionally, for the Halcyon, we've kind of introduced and we offer a brass Halcyon cap for the ion chamber, for the scanning chamber, and this gives you the ability to utilize the imaging system, the built-in imaging system on the Halcyon to position your chambers. So obviously, with the lacking of internal or I should say not internal, but lasers that you could eyeball and visualize from the walls. The brass cap gives you the ability to utilize the imaging system to localize and position those chambers accordingly. We have wireless connectivity. So not only is the pendant itself, as you see here, wireless, it's nice. There's no, you're not tethered to the water phantom, so you can, as you're doing your leveling and setting up the system, you can walk around freely and not have to worry about guiding a cable around the tank. The simple setup and configuration. It's got full set of buttons for setting your origin, for moving in 3 speeds, slow, fast, slow, and step mode to position it. The steps are 0.1 millimeter increments, so you can get very, very fine resolution setup or in your setup. But that being said, we do have the ability to scan in both continuous or in step, but it is a step motor for positioning the chamber. The onboard display, obviously you can see there, you'll always know where you're at. Speeds I mentioned. We have a nice feature too where sometimes if you're doing your setup and you go out and you turn your bias on at the console with the software and you notice something is not quite set up correctly or something needs attention, and you go back into the vault and you forget to turn the bias off, you can turn that on and off from the pendant, which is a nice convenience feature to be able to do that. And additionally to the wireless pendant, the whole system itself can be utilized either in a wired configuration with a serial cable, or we also have a included radio receiver that allows you to use the system wirelessly as well. So you can have a wireless connection from the Phantom itself to the wall, so no cables there as well getting in the way, no trip hazards, things like that. So we have that functionality as well. So it gives you that versatility and convenience. Something that Standard Imaging is very, very well versed at through the years. We've been producing electrometers since the early 90s, and the expertise we use is no different than we had incorporated into our DoseView electrometer. It's a charge digitizing electrometer for high-speed acquisition. It's got a 10 femtocoulomb resolution, so it's a very fine resolution. We've got dual polarity biases and independent bias voltages for the reference and the field. And then some of the time-saving features that I had mentioned, we don't have automatic leveling by choice. We have actually kind of developed a very unique and versatile detector alignment system utilizing what we call the water surface alignment jig. And it's once you get to that setup at the water level, you can do your runouts and you'll very easily visualize where any missed levels or adjustments need to be made very quickly, very easily with the 3-point adjustments. And as you can see here in the cartoon drawing, it shows you how those markings on the alignment jig, if they distort, you'll kind of know where you're at, whether you're high or you're low with your setup, and you can easily adjust that accordingly. And the nice thing too is once you do have that alignment jig set up, then you can take the chamber holder, as you see in the upper right corner, after it's mounted on that setup jig, you can disconnect it from there, replace it on the water surface alignment jig position, the chamber carrier on the Phantom, and it puts it right in the exact position, because we have specific chamber holders for a wide variety of different chambers that are included. Not only our A28 scanning chambers, which again I'll talk about in a minute, but also for farmer chambers, for various available parallel plate chambers. You can see there, we don't necessarily just offer functionality for our X-rated chambers, but if you have other manufacturers' parallel plate chambers, those can be utilized very easily and very accurately as well. And I'm not moving again. My PowerPoint's being a little finicky today, so I apologize about that. There we go. So we've got that alignment jig for fast, precise setup. We've got the multiple detector holders that are included. That water leveling jig is, again, I'm kind of redundant there. I've got two of the same bullets, but apologize about that. Another nice feature in the software, we've got an automatically find beam center, and that's just kind of a quick, easy confirmation that when you set your origin, you're there. So basically, it takes the chamber at a selected depth of your choosing, moves it to that position, and then it will run out in the X and Y directions to find those 50% lines, and then give you any shifts needed to actually center that beam. So it's a very quick and easy check just to make, kind of double check on your setup. So as I mentioned, our X-ray and ion chambers, like electrometers, our experience and length of time providing ion chambers is very long and distinguished as well. Our ion chambers are basically they're all homogeneous materials. The Shanka C5I2 conductive plastic, and that includes the collector guard and the shell. So there's no high Z materials in the beam. They're all virtually pretty much invisible to the beam. There's very little beam perturbation because they are low Z materials. It's a spherical collecting volume, so whether you're doing cross-plane or in-plane, there's no issue there as far as anything you would need to do any post-scan processing because of the collecting volume not being spherical. They're pretty much your standard 0.125 cc collecting volume as well. And the nice thing about our chambers, we're very, the materials we use, the conductive plastic is much more, has much more integrity than say a graphite thimble or things like that. So they're very robust, and because they are, and because we have such high confidence in them, we actually provide a 5-year warranty on our chambers, which can be extended to a 10-year warranty for a small fee. But we basically, they're repairable. They're, if you break a shell, the shell can typically be replaced, things like that. So they are, you don't have to kind of dispose of a whole chamber just because you cracked the shell or there might be issues. We do have a proven track record with our 5-year warranties and available 10-year warranty to take care of any issues you may have with your chambers. Additionally, with our Phantom, as with any of our systems, we have a whole different offering, a complete offering of detectors. Not only our line of ion chambers, from our farmer chambers to our scanning chambers you see here, but also our small volume stereotactic chambers like our A26, which is one of the only reference class micro chambers available on the market. We've got a couple of different stereotactic diodes, both a vertical orientation and a horizontal orientation diode. And then we also something very unique in the industry is our W1 and W2 scintillators for very small fields. Our W. Have a number or message address for Deward. Sorry about that. My Siri was going off on my phone. Don't know why. A lot of strange things going on today. But anyway, the scintillators, the W2 is available in both and comes with either a 1 millimeter by 3 millimeter scintillator or a 1 by 1 millimeter scintillator. So you can do very, very small field measurements with that. It's water equivalent and gives you the ability to again do very, very small fields for your stereotactic work for both scanning and also point measurement. Another nice thing about our system, pretty much everything on the system that might have an issue is user replaceable in the field very easily. The motors, the motion control unit, the cabling, the power supplies. We've made it, we've made the device basically, fields replaceable for most of the components in the system. As I mentioned, the motors are fully interchangeable and they're self-aligning because we use, again, 2 on the redundant motors on the larger axes of the Phantom. So we have that interchangeable there, 4 screws, and that's all it needs to replace a motor. And then the lift card and Phantom both use interchangeable power supplies. So that's kind of a nice redundancy there as well. So that's kind of it for the hardware. I'm going to kind of do a quick overview of the software now. And Our software we rewrote kind of from the ground up about 7 years ago, and then we've kind of been adding to it ever since. Doing those upgrades and updates to it to increase its functionality and give you new features to use. Um, it's easy left to right, top to bottom navigation like you're used to for any Windows environment. We call no hidden features. Everything is right at your fingertips, so you don't have to go digging for different functions and different features and different capabilities within the software. It's all kind of right there for you, and a very intuitive setup for not only your queue setup, but also your measurement and your analysis. It's a very easy system to use, and the nice thing is, like I said, if you're only using it once a year, best case scenario, is not a whole lot to have to relearn. It's very intuitive where you can go, it's like, oh, I remember that step and can easily work through it. So let me jump into the software now real quick. So basically there's 3 tabs. You've got your setup tab, your measure tab, and your analyze tab. The setup tab, this is where you set up your clinics and your machines. So for example, here I've got a clinic that resides in Italy. They shared one of their databases with us, so I've got some of their scan data. So that's the clinic there. They've got their 3 Linacs here, and you can see their different energies for their different systems as well that are set up for. You can see here in their Versa, they've got a number of different energies in both electron, photon, and triple F. Losing my voice, I apologize. But so that's your clinic and your machine setup. Again, very, very easy to add something. You just add it and it'll populate. Same with your machines. Same with the detectors, number of different detectors here. You can add a detector very easily. The name of the chamber, the type of chamber and manufacturer. And as I mentioned, we're kind of agnostic as far as companies go. We don't care what chambers you do. We'd prefer you use our X-rated chambers, but obviously we know that you're going to have probably some other chambers from other companies, so you can add those as well. What type of chamber, whether it's a cylindrical or parallel plate, diode, etc. A nice thing too is that if it's a safety feature, is if it's a diode or some other detector that does not use bias, it will not allow you to turn bias on if you have a diode selected. That kind of saves not only the electrometer from getting blown out or damaging the diode itself by applying bias to it. It just is a nice safety feature. So that's kind of how you add a detector. Very quick, very easy. And then you have them populate here. Scan queues. Scan queues is very easy. It's one of as we look through things, what some of our competitors are doing and how they do it, we feel that our scan queue setup is very, very quick and easy comparatively. I'm going to do a demo setup anyway, so I can do some scanning. But basically, you can see here where your general your parameters are showing you that they're not set, so you just need to address those very quickly. So I'm going to do a test scan here. Use water. I'm going to use I'm going to use MV. I'll probably do 6 MV for demo. I'm going to use MLCs, and I'm not going to have any modifiers, either wedges or if I'm using electrons doing any kind of cutout. Energies. So I'm going to do a 6 MV field size. I'm just going to do a 10 by 10 for demo, or maybe let's do a 20 by 20 instead. You can add different field size. You can do irregular field sizes, non-symmetrical ones. It's just a matter of adding them here. Same with if you're using cones and want to use a diameter versus a rectangular field size, you can do that as well. But as you can see, as I'm moving through here, I'm completing different sections in here, telling me what's next. So I can go to my scan types now. And I'm going to do an in-plane, I'm going to do a cross-plane, and I'll do a depth scan as well. And when you make those selections, you're going to get a few more things to choose from. You have your depths. I'm going to do, maybe I'll do one since it's, I'll do one at Dmax because it's 6 MV. I'll do one at 10, and I'll do one at 20. I'm going to do CAX offsets. I'm just going to do them at central axis, but if I want to do anything like, say, something at 5 centimeters off axis, I can do that as well. It'll populate here. I can either uncheck that or I can delete it completely. And then my last one here is scan mode. Scan mode, basically, here's where I can choose either my step or continuous, as I had mentioned. So I'll do a continuous scan. You'll see, obviously, as you do continuous, it's via speed. If I do step, it's step sizes for my resolution. I can do different zones. I can do either a single zone, which gives me a single resolution all the way across. I can do a multiple zone, which allows me to have a couple of different speeds. I can do speeds in the tails, and if I want more higher resolution in the high gradient penumbra region, I can set that as a higher resolution. As you see here, I'm down to 5 millimeters per second. My flat region, etc. So you have the ability to do that. You can change your zones, zone sizes, and then you can also choose your overscan distances as well. So you can see there with my depth scans and my profiles that I chose, I have a total of 7 scans here. So I'm going to go ahead and save that. And now I'm ready to move to my measure because that's all done in my setup. Preferences is where you set up your time configurations, your delimiters for your CSV export, if you want commas or spaces, periods, etc., things like that. So that's what preferences is. I can move the measurement, and I've got 2 tabs here. I've got my hardware tab where I'm going to set that up. And the nice thing about those few is, again, if you're only using it once a year and you're doing your annuals, maybe like the week before, you just kind of want to get back into the software and kind of play around with it, just kind of reorient yourself to it, you can choose demo mode. So I'm going to choose my demo mode here for my demo 3D. I'm going to connect it, and then I'm going to initialize my scanner. And basically, when you turn your scanner on, it's going to initialize automatically. It'll go to its extent of position for the robot, for the scanning mechanism, and initialize it as such. I can choose my detectors. I'm going to use my my A28 for my field detector, my A28 number 2 for my reference. If you choose not to use a reference detector for some reason, you can do that as well, and that will just gray out the reference offering. My electrometer, I'm going to apply it to my field and my reference, and I'm going to do 300. You see, as my bias is on, it will always tell you what's being measured for your bias. I can zero my electrometer. I can have my position. Let me close a couple of these down. I can have my position here. You can see now I'm set at origin being 0, 0, 0. And I can move to any position I want there. I can go back to my origin. I can move it, and I can set my origin. And here is the locate beam center. So for the locate beam center, what I can do here, I can do it both in the in-plane and the cross-plane. I can do it at a specific depth, say if I want to do it at 10 cm. Turn the beam on, locate beam center. And oh, for some reason, did I not have demo? It should, because I'm in demo mode, it should tell you that basically that it's going to a specific position and what your settings are. So not sure why I did that, but that's the locate beam center. Again, like I said, you can select your different depths, you can locate that beam center, and then it will tell you what your cross plane shift and your in plane shift is accordingly for that. So then I can go to my, again, same thing here with the blue not set and set components here. Will tell you where you need attention to do your setup. Here's my cues. I can load that cue I just made. And that'll be the last one because it's the most recent. This is just telling you that you checked your dose rates and your settings for those are correct. Those were in hardware as well. I didn't show you that, but that's where you set your dose rates here. You can also set your settling times for your scanning steps if you're doing step mode. But here I can zero my electrometer. I can normalize. So if I want to go to 1.5 cm, go to that position. I'm going to normalize at Dmax. I'm normalized. And I can go ahead and start my scans. And why am I invalid? I think oh, I know why. I didn't choose the right electron or the right LINAC either. Apologize. I changed databases this morning for this, and I didn't completely set up everything. So. Nope, that's not it either. Which electron? Which? Oh, my Versa. That's what I was using. Okay. My apologies. Never goes, always goes smoothly. I don't have my Versa in here. This is strange. I should have left my other database in there. I apologize. Let's see if I got it this time. I don't. Well, I apologize. This is a little embarrassing. I should have left my original one, but no matter. Basically, what it will run through here. I don't have the right LINAC set up for this demo because I switched my databases. So I do apologize on that. But basically, once you take your scans, you're going to get over to the analyze anyway, and this is where I can add my scans for measurement analysis. And essentially, the scans I chose here, I've got 6 different scans. I apologize, 6 different scans. They are all 30 by 30 and cross plane. You have the ability to select reference scans, and with those reference scans, it will give you a gamma analysis here, comparing the subsequent scans. So my number 88 and my number 164, I did set as reference scans, and you can see that here in the metrics. You have the 2 asterisks here showing which are reference scans, and then the other 2 scans here, the 91 and 105, which are ID'd there. Give you your comparison to those reference scans. So here, number 91 is a full width half max of 33.35. Number 88, which it's being compared to, is 33.33. I've got my center. I've got all my different metrics here: my flatness, my symmetry, my max percentage, my central axis, penumbra widths, the edge detection, things like that, the center of the beam in centimeters. So those are all shown. And again, like I said, you have your reference scans here noted with the asterisks, and then the scans that are compared to that, to showing you those metrics and comparatively to those scans. With the scanning tools, we have a number of different scan filters that you can apply. We've got a couple different smoothing filters. We've got a point edit, so if you get a point that's kind of out of line, you can edit that accordingly. You can normalize a number of different ways. You can normalize to a specific value. You can normalize to the center of the scan. You can you can center the scan itself. You have the ability to do an average symmetric of the scan. You can mirror the scan positive to negative or negative to positive. You can do a flip of the scan, and you can shift as well. So it gives you a number of different tools to do that. Depth measurements as well. Again, a couple different smoothing filters. You've got the ability to do that point edit on the depth scans. You've got to normalize to a value. You've got you can normalize it to Dmax. You can normalize it to a specific depth. You've got the ability to shift it, and then you also have the ability to convert it to dose. When you initially do your scan, it'll give you ionization numbers, but then it will allow you to actually convert it to dose as well. And part of the setup of the chambers is you put in the chamber diameter of that specific chamber there, and then it will calculate the specific chamber drop you need depending on your protocol. So you have automatic dose conversion for the scan as well. So you can do some of the other features up here. You can do some zooming in on specific areas of the scan. If you want to take a look and see, for comparison there, you can go back to home. You can pan accordingly to as you zoom in. You can zoom in just with the magnifying glasses as well. You always have the ability to go back to home. And then you have tags too, that you can do a single tag or you can do multiple tags showing you all the scans themselves. So you have that capability also. And then some of the tools across the top, as I mentioned, you can do diagonals. You can also do half scans, and those are set up in the scan queue. If you're doing half scans, this is basically a stitching tool which allows you to kind of stitch those two half scans together. If you do have filters applied, say any of these filters over here, you can remove the last filter. You can clear all the filters. So that gives you that capability there to kind of tweak your data. You can put them into scan sets. So if I have a host of scans here, for example, I've got 3 different scans. I can set them up as a scan set, so I can grab that, just that set itself, and I don't have to individually select those scans when I add the scans. Export. There's a number of different export functionalities that you can utilize, including here's all your different treatment planning systems. Obviously Eclipse and Monaco are there. We also can export to Electa's QA platform, Aqua. You can export to Pinnacle, RaySearch, RayPlan, the CyberKnife Precise system as well. And then you can also export to DoseView format. So if you've got the DoseView software on another computer somewhere, say a laptop, and you want to do some analysis off hours at home or wherever, you can export it and import it, those scans accordingly into your system elsewhere. CSV, so you've got the ability to kind of look at your raw data points and kind of manipulate it and utilize Excel as you see fit. We can also export obviously PDDs, or the percent depth dose tables. And then you can also do a calculated TPR as well from those percent depth dose tables. So those are the export types. And the import, that allows you to import those DoseView type files that you may have from another PC. Another nice tool we have, if you have legacy scans from an older IBA or PTW system that you have replaced with the DoseView, we have a scan import tool that allows you to import legacy scans from PTW and IBA into DoseView for analysis. So you can look at your older scans and your newer DoseView scans and do comparisons there as well. And then finally, our reports gives you the ability to do a couple different types of reports. You can either do a CSV report, or you can do an isodose curve on a PDF as well. So it gives you the ability there to do the isodose or CSV exports. So that is kind of it as far as the software goes. Again, I apologize. I've got to go back to my old database so I can have the correct Linux set up in there. But as far as that goes, let me jump back into the PowerPoint. I knew I was going to do that. I went right back to the beginning. Come on now. This is not my best showing today, I got to admit. But anyway, let's go to our summary. The hardware, we're very take great pride and resolve in building a very structurally rigid design, which gives you an unparalleled repeatability and accuracy of all those axes of zero point 0.1 millimeter precisional accuracy of per axis. Again, like I said, that's the X, Y, and Z axes for accuracy of the 0.1 millimeter. It's a very quick system setup. It's very unique as far as how we do our chamber alignment, and it's actually very quick to do so. We've got a system over at the University of Wisconsin Calibration Lab. They use our water phantom, and the gentleman who is kind of does the scanning can get that set up in about 15 minutes. It's actually very quick. And he's looked at other and used other systems in the past, even with the automatic leveling, and he feels that ours is superior just because it's not something you have to kind of rerun the protocols and rerun the auto leveling if something was off. It gives you the ability to kind of fine tune it and really get an accurate setup. That wireless functionality, again, for ease of use, both for the pendant itself, but also the whole system. The dual channel electrometer with the independent bias, again, that's something that we've had a lot of experience over the years in building very high quality, very accurate reference class electrometers. And the detector alignment system, as I kind of mentioned, getting that set up quickly and easily to get you scanning very quickly helps you streamline your annual measurements. And then the software, again, it's very easy, left to right, top to bottom navigation. The quick queue setup has copy and editing functions. That's one of the things I really didn't touch on just because of time, but gives you the ability to kind of grab a set of scans and easily edit those so you don't have to do each individual energy or each individual field size, things like that for everything. It gives you some quick shortcuts. No hidden features, everything's at your fingertips. You have the ability of step or continuous scanning with the multiple zone resolutions. You have full export to a number of different treatment planning systems and different formats. The import functionality, as I mentioned, for legacy scan data from IBA and PTW, that you can bring all your older scans in for comparison. Straightforward scan process, post-scan processing and metrics, and then the different scan comparison options. Not only your metrics that can be compared side by side to a reference scan, but also that gamma comparison as well. So that's kind of what I've got for you today. I went a little longer than I wanted to. I apologize. I thank you very much for kind of hanging in there with me through a couple hiccups. But I want to thank you. And like I said, if you want to have a deeper dive and kind of go through things more in depth and see the scanning itself. Please feel free to contact us at standardimaging.com. You can contact me directly, H. Peterson at standardimaging.com. And you can also access your account rep or your regional rep by sales at standardimaging.com as well. So I thank you again for your time. I'm going to take a peek here, see if there are any questions. Looks like there may be. Which position is best regarding accuracy among 4 quadrant positions for ion chamber positioning? So I'm not really understanding the question as far as a quadrantal position for ion chamber positioning. It gives you, you have the ability to position your chamber at any position within the phantom automatically with the not only the phantom but the software as well. And being that they are spherical collecting volumes, it really any position should be okay. If you want to, again, email me with that question. Yeah, my email, you should still be able to see hpeterson@standardvision.com. I can certainly find that out. I'm not quite sure what you're asking as far as a quadrenal position for the ion chamber, but definitely find out for you. Other than that, I greatly appreciate your time for spending with me and going through the dose view. Again, I'd be happy to give you a deeper dive of the software and the system individually if you contact your rep, and we can set that up. So thanks very much.